Okay. Testing 1, 2. Hey, hey, here we are. Ha! Okay, that's now going to be on the video when I post it. So if you need a laugh later, you can go back and look at that. Anyway, so lesson 0.1, and we're going to start with number 1. Solve 5x minus 9 equals 3x plus 7 and check. It's a pretty straightforward algebra problem, don't you agree? Here I am, I'm back again. This is good practice for me for later. So you have 5x minus 9 equals 3x plus 7. What are you going to do first? That's exactly what I would do. Minus 3x minus 3x. You're left with 2x minus 9 equals 7. Add 9 to both sides. 2x equals 16, so x should equal 8. Okay, so for number 1, again, pretty straightforward problem. When we get to number 2, I love these problems. Some people do not, because to me, number 2 is like a puzzle. I have asked you to solve for the letter P in that one. So we have A equals P plus PRT. The problem is that P is in 2 of the expressions right now. So how can I get it out of those expressions?
Could you divide RT on both sides?
Well, you could, but this doesn't have an RT in it. Okay, so what we have to think about now is pulling P out. The only way to do that is through factoring. Right? If I factored P out of both terms, now what I have is 2 factors where P is isolated from the other stuff. Does that make sense to you guys? So now we can divide both sides by the 1 plus RT. So A over 1 plus RT would equal P. You guys get that? All right. Number 3, it is finding 4 consecutive even integers. So this is a concept that hopefully you have seen in the past about consecutive numbers. And if they were just 1, 2, and 3, you'd have x plus 1, x plus 2, right? But they're even, or if they're odd, you would be adding 2 to get from the first number to the next number. So by values of 2. So the first number would be x, then x plus 2, x plus 4, x plus 6, and so on. Those are the consecutive even numbers. And it asks us to add 4 consecutive even integers so that their sum, these 4 added up, first 3 exceeds the 4th by 8. So we're going to add the first 3, x plus, the second one is x plus 2, plus the third one exceeds the 4th. This exceeds the 4th, which is x plus 6. Oh, I guess it exceeds it by 8, right? Yeah. Yeah, so it's more than, 8 more than. Okay, so that would be how I would set the problem up. And then we're just going to combine up our terms and simplify. So on this side, I have 3x plus 6 when I combine everything. Over here, I have x plus 14. Combine like terms, this is going to be 2x. Subtract 6, this will be 8. So my original number is 4. So what are my 4 consecutive even integers? The first one is 4.
No, 14.
What is 8 plus 2?
Oh, 10.
10. So remember, they're consecutive evens. Once you find the first one, you use 4, 6, 8, 10, right? Okay, are we good with this? Should I leave it a minute? Are we good?
Yes.
Okay. The next one is talking about the perimeter of a triangle. How do you find the perimeter of a triangle?
2 times 8 plus 2 times the length.
That's a rectangle. Very good, though, that you remembered that one.
Is it 1/2 base times height?
That's the area.
That's the area. Isn't it like you add up 3?
That's right, you add the sides. So we're gonna say side 1 plus side 2 plus side 3. This is being algebraic in the way you just add up the sides. Now let's see what it says to me. It says one side of a triangle is 1/3 the perimeter. So I'm gonna say that side 1 equals 1/3 the perimeter. Okay? Then it says the second side, side 2, is 1/5 the perimeter. And then finally, the third side is 7 meters. Find the perimeter of the triangle. Okay? So I have a formula, and all I need to do now is replace these variables with these values, and I'll be able to solve for the perimeter. Okay? So let's do that. So P, using my formula, S1 we said was 1/3 P, plus side 2 is 1/5 P, plus the third side, which was 7. We're gonna have to combine up all of the P's, combine these together. Well, you're gonna have to have a common denominator here, which would be 15. Do you agree?
Yes.
Okay. So this is gonna be P equals 5/15P plus 3/15P plus 7, 8/15. So this is P minus 8/15P equals 7. Well, this would be 15/15, wouldn't it? This one. So 15/15, I'll just go ahead and put that out in front of it, minus 8/15 would be 7/15P equals 7. Solve for P. Multiply both sides by 15/7. Right, so this goes away, and P equals 15 meters. And look at us, we are done with the front of this worksheet already. Okay, now we get to the back. Woohoo! Yeah, yes. But I don't want to hurry. If you need a minute, just let me know, okay? Okay, yeah, those of you who have a packet, it's a 2-page thing, right? Mine is done as front and back, so. I think Naya, you have the front and back too, right? All right, so we're good with this? All right, let's erase that. And you notice on the back, now we've gotten to the word problems. So number 5, the distance along a shipping route between San Francisco and Honolulu is 2,100 nautical miles. If one ship leaves San Francisco at the same time the other leaves Honolulu, and if the former travels at 15 knots and the latter at 20 knots, how long will it take the two ships to rendezvous? How far will they be from Honolulu and San Francisco at that time? So that was a lot of information, okay? So we have this distance of 2,100 miles, and we've got, what can I put over here? A palm tree, right? There's my palm tree, because we're in Honolulu, put some coconuts in there. Okay, a couple of coconuts up there in the tree, and put put some bars on there so it looks like that. Okay, and then over here, what could we have? How about the Golden Gate Bridge? What do you think? Golden Gate Bridge? Yeah. Okay, that's the Golden Gate Bridge, and there's a little car on there going across the bridge. Okay, so there we go, 2,100 miles apart. So we have somebody leaves, where do they leave first? If one leaves, so here's my little ship. He's leaving San Francisco at the same time another one leaves from Honolulu. Okay, so this one has a sail on it, okay? Two different ships. You good? They're leaving at the same time, and they're going a certain rate. So what do we have? We have two DIRT problems. Distance equals rate times time, okay? So his DRT, his DRT. What do we know about their time? It's the same time. So T is the same for both of them. I don't need to replace it with anything. The rate, though, if we're leaving from San Francisco, we're going 15 knots. So he has D equals 15T. This guy is going 20 knots. So he is D equals 20T. What do I know about their distance? At some point, they're going to meet up, right? And they probably meet more in this direction because this guy's going slower, but regardless. What I know is that if I add his distance plus his distance, they will add up to 2,100, right? So that's what I'm going to do. I'm going to say his distance, which is 15T, right? His distance is 15T, plus his distance, which is 20T. Add them together, they must equal 2,100. So we have 35T equals 2,100, and divide by 35, and that's going to give you something. I bet it's going to give you 60. Thinking. On your first blank, because you'll notice that you have two blanks, the first blank you should write 60 hours because that's their time. On the next blank, they want to know how far they are from both places. So if this is your first blank, on your second blank, you could say San Fran, or however you want to abbreviate it, and Honolulu. How far is he from San Francisco? And how far is he from Honolulu? You would simply take 60 and plug it in to these equations up here, and it would give you a distance. So for San Francisco, we're going to do 60 times 15, and that will give you 900 miles. And then I'm just going to say this is 1,200 miles because I know it's 2,100 minus 900. Okay? Okie doke. Number 6. Are we ready to move on? Yeah? Okay. Okay, there goes my pictures. The first pictures of the year, guys, and they happen to be for you. Don't you feel special? Yay. Hey, I just want you to know, Jaheim, I impaled somebody twice yesterday in music class, and he was instructed that he needed to fall out, and he did it very well. So you would be proud. You'd be proud. All right, number 6. An excursion boat takes 1.5 times as long to go 360 miles up a river than to return. If the boat cruises at 15 miles per hour in still water, what is the rate of the stream? So this is a distance problem, but it has a current involved. So remember, if you have a current, you would have R plus the current, however rate, whatever his rate, plus the current times his time. Then you would also have the distance being R plus C, R minus C, his rate minus the current, this is when he's going slower, times the amount of time that he travels. Okay, So we're going to say he's going on both occasions. In this problem, he's going 360 miles both ways. So the distance is the same. And what is the rate of the return? So we're actually solving for the rate, right? So 15 miles per hour in still water. So we know that this is 15. And I don't know anything about the current, but I do know that 1.5 miles, an excursion boat takes 1.5 times as long All right, I'm going to solve both of these for t, okay, because the thing is dealing with time. So this is going to be 360 over 15 plus c. Here he's going faster. The two equations are going to be equal to each other. This is 360 over 15 minus c, but his time is 1.5. I need to put that 1.5 on the other side. Because his time is 1.5 times as long as this. So this is always the equation that messes me up every single year. So we really have ratios here. These are two ratios. So what I'm going to do is I'm going to multiply this fraction by 1.5, which now is going to give me a numerator of 540 over 15 plus c equals 360 over 15 minus c. Well, if you have ratios, you can cross multiply. So that means that this is going to be 540 times, I'm making sure I'm still on the camera, 15 minus c. And then multiply here, you're going to end up with 360 times 15 plus c. Then you're going to distribute the values, and I figure you guys know how to do that, so I'm just going to show you what you're going to end up with. Why does that seem wrong to me? It's not. It is correct. So this is going to end up being 8100 minus 540c. This is going to be 5400, yeah, 5400 plus 360c. Now we're going to solve for the current. That's really what we want to know. So if we combine up our like terms, just for the sake of time, I'm just going to do this. It's 900c equals 2700. And the current is going 3 miles per hour. And that's what I wanted to know. What is the rate of our current? Okay, we only have 2 more. And how long have we been going? 18 minutes. Okay? Are we ready to move on? Do we have this written down? So the next one is an advertising firm has an old computer that can prepare a whole mailing in 6 hours. With the help of a newer model, the job is completed in 2 hours. How long would it take the newer model to do the job alone? This is a work problem. Okay? The time that it would take both of them working together is t. A is the time it takes one guy to do it by himself. B is the time it takes the other guy to do it by himself. Okay? So this is what we're going to do. We're going to say an advertising has a firm can prepare a whole mailing in 6 hours. With the help of the newer model, the job is complete in 2 hours. So T in this case is 2 hours. If they work together, it would take them 2 hours to complete this job. All right. So the advertiser can prepare a mailing in 6 hours. So his original time was 6 hours. We don't know how long it took this guy working alone. So that's what we're going to do with this. We're going to solve for B. All right, so I am going to, let me see, how do I want to do this? Let's isolate the B variable first. I think that's a good idea. And this is the same as 1/3. So you have 2 over B equals 1 minus 1/3. So this would be 2/3. So how long, at this point, you should know the answer. What does B equal? Okay, this is number sense, and it's a good time for you to see. You can go through and solve this if you want to, but look at the fractions. Do they have the same numerator? The only way for them to be equivalent is then if the denominators are equivalent. So what is B? It's 3. Okay, so like I said, you can solve it if you want to. You can cross multiply. You would get 2B, right? Multiply these equals 6. And then divide by 2, and B would equal 3. Okay? So if you need to work through the process, because they're not always going to be that obvious, but it's nice if you see it to go, oh, I know what it must be now. All right, we have one more. Okay, this is a mixture problem. And Naya, we did these in MCR with the box. You remember doing those? Okay, and that's how I think I'm going to show you this. All right, so let's see what we have. How many liters of a mixture containing 80% alcohol should be added to 5 liters of a 20% solution to yield a 30% solution? All right, so I'm going to create a little box. This is always my go-to. And the box is always the same. We start with a name, and then we have an amount times, in this case it's a concentration, but it could be cost as well. A concentration, and it's going to equal some total. Okay, so now what we'll do is we'll go back and say, what did they give me? They gave me how many liters of a mixture containing 80% alcohol. So this is my 80% solution. I'm going to add it to a 20% solution, and I eventually want a 30% solution when I'm done. And we know that we're going to add it to 5 liters of the 20% solution, but I don't know how many liters I'm adding of the 80%. So there's my unknown quantity. Well, when I get done, I'm going to have X plus 5 liters, won't I? So I can fill this box in. This up here tells me to multiply the amount times the concentration. Well, if it's an 80% solution, what is the concentration of alcohol? It's 80.80, right? Just write it as a decimal. This now is going to be 5 times 0.20. That's his solution value. This one is going to be 0.30. The last column tells me what to do with my math. It's going to say, take this first amount, add it to the second amount, and it will equal the third amount. And that's where we'll gain our equation. So in the first box here, we're going to say 0.80 times X. Here we're going to say 5 times 0.20, which would just be 1. The last one is going to be 0.30 times X plus 5. So now my equation is going to be, the first box in the last column plus the second box equals the third one. And I'm gonna go ahead and distribute that 0.3 times 5, so this should be plus 1.5, correct? Yeah. And then we just simply do our math. Okay, but having the box, for me, that's just my go-to. I really, really like it, rather than writing an equation in two variables. Yeah, this just, for me, it makes it easier. So we're gonna do the math. We're gonna have 0.5x equals 0.5. So x equals 1 liter. So we need to add 1 liter of that 80% solution to the 5 liters of 20%. And that, my friends, is the end.